In this section of the MECH study group, we will be covering the topic of safety and support. Approximately 9% of the questions asked on the MECH exam will be on the area of safety and support, which means that about 9 of the 100 questions will be about the concepts of responding to emergency situations, training hospital personnel, and disposing of hazardous waste. We are going to be covering the following tasks that come directly out of the MECH test preparation manual. The candidate should know gas and arc welding safety, the safe operation of hand and power tools, the lockout and tagout procedures, how to handle and use sharps containers, ladder safety, lifting techniques, infection control and bloodborne pathogen safety, and finally, national and state OSHA regulations as they apply to maintenance. The first area of knowledge to understand is gas and arc welding safety. Be sure to keep gas and oxygen cylinders at least 20 feet apart when not in use, or separate them with a proper firewall. Also, store cylinders away from other flammable and combustible materials. Store extra gas and oxygen cylinders separately, at least 20 feet apart or separated by a proper firewall. Also, keep cylinders away from physical damage, heat, and tampering. Store cylinders in an upright position. Chain them securely to keep them from falling over, and chain the welding rig securely to prevent it from falling as well. Next, close cylinder valves before moving. Protective caps or regulators should also be kept in place. Roll cylinders on the bottom edge to move, but make sure that you do not drag them. Minimize cylinder movement when transporting. Some general gas welding safety tips. First, lift gas cylinders only with equipment designed for that use. Also, inspect torches and clean only when with the proper tools. Use only torches that have blowback protection. Inspect equipment for leaks at all connections using approved leak test solutions. Inspect your hoses for leaks and worn places, and replace bad hoses as necessary. Have a fire extinguisher easily accessible at the welding site. Also, protect hoses and cylinders from sparks, flames, and hot metal. Make sure to use a flint lighter to ignite the flame. Also, practice proper regulator precautions, including stand to the side away from the regulators when opening cylinder valves. Use two-stage regulators whenever possible. When using a single-stage regulator, open cylinder valves very slowly. This keeps sudden high pressures from exploding the regulators. When using a single-stage regulator, only open the acetylene cylinder valve a quarter to 3/4 of a turn. Make sure to leave the wrench in place. That way you can close the cylinder quickly in an emergency. Also, open and light the acetylene first. Then open and adjust the oxygen to a neutral flame. When shutting off the torch, close the acetylene torch valve first. You might hear a pop as the oxygen blows out the flame, but the flame will not burn up the acetylene line. When all is said and done and you're finished, make sure to close the cylinder valves. Bleed the lines to take pressure off the regulators. Neatly coil the hoses and replace your equipment. Arc welding has some very specific concerns regarding shock hazards. The hazard of electric shock is one of the most serious and immediate risks facing you as a welder. Contact with metal parts, which are electrically hot, can cause injury or death because of the effect of the shock upon your body, or a fall which may result from your reaction to the shock. The electric shock hazard associated with arc welding may be divided into two categories, which are quite different. The first is primary voltage shock, which is typically 230 or 460 volts. The second is secondary voltage shock, which typically is between 20 to 100 volts. The primary voltage shock is very hazardous because it is much greater voltage than the welder secondary voltage. You can receive a shock from the primary or input voltage if you touch a lead inside the welder with the power to the welder in the on position, while you have your body or hand on the welder case or other grounded metal. A secondary voltage shock occurs when you touch a part of the electrode circuit, perhaps a bare spot on the electrode cable. At the same time, another part of your body is touching the metal upon which you're welding. To receive a shock, your body must touch both sides of the welding circuit, the electrode and the work, at the same time. Some other tips to avoid electrical shock. Use well-insulated electrode holders and cables. The electrode holder or stinger should be in good condition with no cracks or missing insulation. Never leave the welding electrode in the electrode holder or stinger when not attending the work. Make sure welding cables are dry and free of grease and oil. Keep welding cables away from power supply cables. Wear dry, hole-free gloves. Clothing should also be dry. Insulate the welder from the ground by using dry insulation, such as a rubber mat or dry wood boards. Ground frames of welding units. And never change electrodes with bare hands or wet gloves. Be sure to protect your body from welding spatter and arc flash with protective clothing including woolen clothing, welding jackets, flame-proof aprons, gloves, properly fitted clothing that is not frayed or worn, long-sleeve shirts, straight-leg trousers that cover your shoes, fire-resistant capes or shoulder covers for overhead work, and finally, leathers to protect specific body parts or areas. Be sure there is adequate ventilation available when welding in confined areas or where there are barriers to air movement. Natural drafts, fans, and positioning of the head can help keep fumes away from the welder's face. Ventilation can be considered sufficient if the room or welding area contains at least 10,000 cubic feet for each welder. The ceiling height is not less than 16 feet. Cross ventilation is not blocked by partitions, equipment, or other structural barriers. Or finally, if welding is not done in a confined space. If these space requirements are not met, mechanical ventilating equipment must be used. Equipment must exhaust at least 2,000 cubic feet of air per minute for each welder, except where local exhaust hoods or booths or airline respirators are used. Some additional precautions you should follow is to consider the need for a fire watch. Operators may not become aware of a fire starting while welding or cutting. Their vision is seriously hampered by the welding goggles and dark lenses. Depending on the circumstances of the work location, it may be advisable to have a fire watch to operate a fire extinguisher and sound a fire alarm in the case of a fire. Make sure to know the local fire codes for welding and cutting. Follow the information on fire protection during welding or cutting operations in the National Fire Protection Association Standard, or NFPA number 51B. The next section we're going to be covering is the safe operation of hand and power tools. First, make sure to start with a safe work area. Keep your work area clean and well lit. Cluttered benches and dark areas invite accidents. Do not operate power tools in explosive atmospheres near flammable liquids, gases, or dust. Power tools create sparks which may ignite the dust or fumes. Keep bystanders, children, and visitors away when using a power tool. Distractions can cause you to lose control. Next, make sure to address electrical safety. Grounded tools or three-prong cords must be plugged into a properly grounded installed outlet. Never remove or cut off the grounding prong or modify the plug in any way. Double insulated tools have a polarized plug. One blade is wider than the other. This plug will fit into an outlet only one way. Do not change the plug in any way. When using a power tool, don't touch grounded surfaces such as pipes, radiators, ranges, and refrigerators. There is a high risk of electrical shock if your body is grounded. In damp locations, only plug your tool into a ground fault circuit interrupter, or GFCI. If the work area does not have a permanent GFCI on the outlet, use a plug-in GFCI. Wear rubber gloves and footwear. Don't use or leave power tools in the rain or wet conditions. And be sure to replace damaged cords immediately. There are some rules about extension cords that should always be followed. First, when using a power tool outside, use an extension cord marked for outdoor use with WA or W. These cords are made for outdoor use. Next, extension cords with three-prong grounding plugs must be plugged into three-prong outlets when using grounded tools. Next, replace damaged or worn cords immediately. The wire gauge and length of the extension cord must be able to handle the amps of the tool. Find the amps on the tool's nameplate and use this or another similar chart shown on the screen to determine the necessary wire gauge for your extension cord length. There are numerous types of tools you will need to be familiar with, including those listed on the screen. Always read and understand the tool's operator's manual, tool markings, and the instructions packaged with the accessory before starting any work. Stay alert, watch what you are doing, and use common sense when using a power tool. Do not use tools when you are tired or under the influence of drugs, alcohol, or medication. Be sure to dress right. Do not wear gloves, loose clothes, or jewelry. Be sure to keep handles dry, clean, and free from oil and grease. Be sure the power tool switch is off before plugging it in or inserting a battery pack. Do not carry tools with your finger on the switch. Remove adjusting keys and wrenches before turning the tool on. Always keep a firm footing when using power tools. Be sure you have balance and control before you start the job. Make sure to use safety equipment. Always wear eye protection, a dust mask, non-skid safety shoes, hard hat, or hearing protection must be used when needed. The reference to safety goggles or safety glasses in product-specific sections provides potential options. Always refer to the tool's operator's manual for the specific eye protection recommended, which should be marked as complying with current national standards. Unplug tools or remove the battery before changing accessories. Keep hands away from rotating or moving parts. And be sure to keep guards in place and working properly at all times. Always follow the manufacturer's instructions specific to the piece of equipment you are operating. For additional general information for a particular type of tool, please visit the website on the screen. We are now going to review lockout-tagout procedures. Only authorized employees may administer lockout-tagout devices. The same authorized person who locks or tags a device must remove the lock tag. Special safety procedures must be followed if the authorized person is not available to remove the lock or tag. Typically, locks are assigned to authorized persons for individual use. The OSHA standard for the control of hazardous energy lockout-tagout is found in Title 29 of the Code of Federal Regulations, or CFR. Part 1910.147 addresses the practices and procedures necessary to disable machinery or equipment, thereby preventing the release of hazardous energy while employees perform servicing and maintenance activities. The standard outlines measures for controlling hazardous energies, which could be electrical, mechanical, hydraulic, pneumatic, chemical, thermal, and other energy sources. Some definitions you will need to understand include authorized employee, which is an employee who locks or tags machines or equipment in order to perform servicing or maintenance. Also affected employees, which are not designated to perform lockout-tagout, but operate or otherwise come in contact with equipment covered by lockout-tagout. Other employees are defined as employees working in an area around equipment covered by lockout-tagout. Some additional definitions include energized, which can be defined as when machines or equipment are connected to an energy source or contain residual or stored energy. An example would be a spring. An energy source can be defined as any source of electrical, mechanical, hydraulic, pneumatic, chemical, thermal, or other energy. An energy isolating device can be defined as a mechanical device that physically prevents the transmission or release of energy. Examples include manually operated electrical circuit breakers, disconnect switches, push buttons, selector switches, and other control circuit type devices are not energy isolating devices. Types of lockout devices include padlocks, circuit breaker locks, valve locks, electrical plug locks, wall switch locks, cable locks, hasps, group lockout devices, or boxes. Lockout can be defined as the placement of a lockout device on an energy isolating device in accordance with an established procedure, ensuring that the energy isolating device and the equipment being controlled cannot be operated until the lockout device is removed. Tagout can be defined as the placement of a tagout device on an energy isolating device in accordance with an established procedure to indicate that the energy isolating device and the equipment being controlled may not be operated while the tagout device is used. The law requires that lockout devices be used in conjunction with tagout devices whenever a system can be locked. Placing a tag only is not sufficient unless the device is not capable of being locked to prevent re-energization. Energy sources include a variety of types. Pneumatic sources of energy can often be stored even when a device is turned to the off position. Pressurized devices must be bled or released prior to work being performed to eliminate the safety hazard. Be sure to check for and then release potential energy stored in devices such as springs in a mechanical device or capacitors in an electrical device prior to performing work on a device. Sometimes overlooked by workers, be sure to be aware of and protect against energy sources in the hydraulic, chemical, and thermal categories. They can be just as dangerous and need to be equally protected against by using lockout-tagout procedures. Lockout-tagout devices must be standardized for your site. All employees working around equipment that can be locked out must be trained on the meaning of lockout-tagout and safety measures. Lockout devices must be durable and withstand environmental exposures and time. They need to identify the owner applying the device, and it must be a device used for controlling energy. They're not used for purposes other than lockout, and they should be standardized in the facility, meaning that the color, shape, or size should be standard. Tagout devices should be standardized to the same print or format as lockout devices. They should be durable and resistant to damage by water, acidic or alkali chemicals, and substantial to prevent accidental removal. They should warn against specific hazards conditions if machine or equipment is energized. And they should include a legend for things like do not start, do not open, do not close, do not energize, and do not operate, or others. Authorized persons must be trained in lockout-tagout regulations and practices. Authorized persons must be designated by the site and are responsible for implementing the lockout-tagout program safely, including notifying affected employees of work to be performed requiring lockout-tagout, reviewing lockout-tagout procedures, performing de-energization of equipment, lock and tag out of all energy sources in a particular system, verify the system is de-energized, complete the maintenance work, verify the equipment or machinery is ready to return to service, notify affected and other employees that work is complete, remove the locks and tags, and finally, place equipment back into service. Next, we will discuss how to handle and use sharps containers. Sharp containers need to be the following: puncture resistant, leak proof on the sides and bottoms, appropriately labeled and color coded with warnings. They must have universal biohazard symbols if biohazardous waste is available. They must be closable by a lid, flap, or door, and then stored in the upright to prevent spills. They must be replaced routinely and not overfilled. Reusable containers must not be opened, emptied, or cleaned in a manner that will expose workers to sharps. Employees handling containers must be fully closed and latched or locked to prevent spillage. The containers must be placed into secondary containers if they're leaking. They must be discarded when the fill line is reached. Usually it's approximately 3/4 of the way full. They do not overfill sharps containers. And if blood vials are disposed of in sharps containers, they must be discarded within 7 days. Hazards associated with handling sharps containers include needle or sharp punctures to the skin and exposure to bloodborne pathogens, so workers should always wear personal protective equipment when handling sharps containers. Do not handle sharps containers that are overfilled. When disposing of sharps containers, always wear the appropriate PPE, which is safety glasses, gloves, and coveralls. Ensure the sharps container is not overfilled beyond the fill line, or again, about approximately 3/4 full. Do not touch sharps containers that are overfilled. Call an appropriate safety professional. And finally, ensure the lid is fully closed and latched or locked prior to disposal. Next, we will discuss ladder safety. Be sure to read and follow all labels or markings on the ladder. Also, avoid electrical hazards at all times. Look for overhead power lines before handling a ladder. Avoid using a metal ladder near power lines or exposed energized electrical equipment. Always inspect the ladder prior to using it. If the ladder is damaged, it must be removed from service and tagged until repaired or discarded. Always maintain a 3-point contact on the ladder when climbing, meaning you should always have 2 hands and a foot, or 2 feet and a hand attached to the ladder at all times. Keep your body near the middle of the step and always face the ladder while climbing. Only use ladders and appropriate accessories for their design purposes. Ladders must be free of any slippery material on the rungs, steps, or feet. Do not use a self-supporting ladder in a partially closed position. Do not use the top step or rung of a ladder as a step unless it was specifically designed for that purpose. Use a ladder only on a stable and level surface unless it has been secured to prevent displacement. Do not place a ladder on boxes, barrels, or other unstable bases to obtain additional height. Do not move or shift a ladder while a person or equipment is on the ladder. An extension ladder or straight ladder used to access an elevated surface must extend at least 3 feet above the point of support. Do not stand on the 3 top rungs of a straight, single, or extension ladder. The proper angle for setting up a ladder is to place its base a quarter of the working length of the ladder from the wall or other vertical surface. A ladder placed in any location where it can be displaced by other work activities must be secured to prevent displacement, or a barricade must be erected to keep traffic away from the ladder. Be sure that all locks on extension ladders are properly engaged. And do not exceed the maximum load rating of a ladder. Be aware of the ladder's load rating and of the weight it is supporting, including the weight of any tools or equipment. The next section we will be covering is lifting techniques. Proper lifting techniques include bending at the knees and never at the waist when picking up loads. Proper lifting technique is more effective than back braces or other devices for protection from back injury during lifting. Maintain the natural curvature of the spine. Be sure to plan the lift. Remove any items that are blocking your path, and plan where the load will be set down. Ensure that the floor surface is not slippery, and open doors or move obstacles before lifting. Next, bend at the knees to pick up and put down the load. Hug the load close to your body during transport. And if the load is too heavy, do not try to lift it yourself. Get help. And always remember to use a mechanical lifting device whenever possible. Proper lifting procedures should include: take a balanced, wide stance with feet shoulder width apart. Squat down with the legs to lift. Get as close to the load as possible. Maintain a secure grip and hug the load close to your body. Lift gradually using your legs. Keep your back and neck straight. Once standing, change direction by pointing your feet and turning your entire body. Avoid twisting at the hips. Finally, squat down with the legs to set down the load. Do not bend at the waist at all. The next section we will be reviewing is infection control and bloodborne pathogen safety. OSHA estimates that 5.6 million workers in the healthcare industry and related occupations are at risk of occupational exposure to bloodborne pathogens. Needle sticks occur most frequently in patient and operating rooms. To help protect workers, OSHA's bloodborne pathogen standards include the following requirements. All employees who are occupationally exposed to bloodborne pathogens must be identified. Employees must have initial and annual training. Bloodborne pathogen exposure control plans must be in place and accessible. Hepatitis B vaccination must be made available. A safe needle sharps program must be implemented. Standard precautions should be used whenever possible. Workers should assume that all patient fluids contain bloodborne pathogens. Personal protective equipment should be worn when contact is made with any fluid or potentially contaminated surfaces or objects. Notice that saliva is not considered OPIM or other potentially infectious material. However, all body fluids of undetermined status should be considered contaminated. Some of the best ways to prevent exposures is to follow safe work practices and safe sharps use practices. Receive your HPV vaccination and follow containment and engineering controls, particularly those that are posted at the entrances to patient rooms. Be sure to wear the proper personal protective equipment, or PPE, and follow the decontamination procedures when exiting potential exposure areas. There are some additional safe working practices that should be followed to help ensure your safety. 1. Do not eat, drink, or smoke in areas where bodily fluids or bloodborne pathogens contamination may exist. Use appropriate sharps containers and do not overfill sharps containers. Be sure to wear the appropriate personal protective equipment when working around blood and OPIM. Some various types of equipment you could wear is lab coats, coveralls, laboratory coats, gloves, and safety glasses or goggles. Again, follow the appropriate decontamination procedures. You should also be aware of the definitions of decontamination, disinfection, and sterilization. Decontamination is the destruction or removal of microorganisms to some lower level, not necessarily zero. Disinfection is the chemical or physical treatment that destroys the most resistant microbes and viruses, but not spores. And the third is sterilization, which is the complete destruction of all viable organisms. For additional information, please visit the most up-to-date version of the OSHA regulations. Next, we will go through national and state OSHA regulations as they apply to maintenance. We will not be able to review every section of the federal OSHA regulations, but you should familiarize yourself with the sections shown on the screen prior to the MECH examination. Note that some of these topics have been covered in other study guides. State regulations are often more stringent than federal OSHA regulations. Cal OSHA supersedes Fed OSHA whenever a specific California regulation exists. We will not be reviewing state-specific OSHA regulations because this study guide is focused on those areas that might be on the nationally focused MECH exam. However, you should familiarize yourself with these regulations to ensure you are following the appropriate regulations. Next, we will go over some highlights of the OSHA regulations that will likely be covered on the exam. First, some confined space highlights. Permit-required confined spaces contain any of the following: hazardous or potentially hazardous atmospheres, contains a material that can engulf the entrant, has limited means of entry or exit, or contains any other recognized safety hazard. Non-permit required confined spaces does not contain or have the potential to contain any hazard capable of causing death or serious physical harm. Only authorized persons trained in confined space entry and emergency rescue may enter permit-required confined spaces. A written entry permit must be issued whenever confined space entry is required. Permit must be posted at the site of entry. A hazard assessment or job safety assessment must be performed as part of the permit issuance. And finally, emergency procedures must be in place for rescue. Some respiratory protection highlights. Respiratory protection program is needed when respirators are required for work. Employees wearing respirators must have a medical exam and respirator fit test. Annual training is required, and the employer must furnish appropriate respirators for the hazard. Note that respirators may be worn by workers on a voluntary basis. However, regulations still apply. Voluntary respirator programs cannot be used in place of a regulated respiratory protection program when a hazard requiring protection is present. Next, we'll review some highlights for occupational noise exposure. Occupational noise is a good example where the state regulations are more stringent than the federal. The federal exposure limit is 90 decibels average over 8 hours, while Cal OSHA, which is the state, is more stringent at 85 decibels averaged over 8 hours. A hearing conservation program is required when 8 hours of average noise exposures exceed decibels of 90 at the federal and 85 at the state level. Noise exposure monitoring and hearing exams must be performed for employees exposed to levels above 90 at the federal level and 85 at the state decibel level. Hearing protection devices must be assigned to employees. Areas with high noise exposure of greater than 90 at the federal level and 85 at the state decibel level must have signage posted. And annual training must be conducted with all employees. You can follow along with our final section of our safety and support review inside the MECH test preparation manual. These questions are pulled directly from the manual, and explanations have been provided to help you better understand the concepts being reviewed in the questions. CAT test question 1. Before entering a confined area, what should be done? A, look into the area with a flashlight. B, determine if anyone is in the confined area. C, place a safety line into the confined area. D, file the permits. Answer D is the best answer here because filing the permits is the first step anytime work is to be done or completed in a confined space. When filing the permits, confined space program managers will be able to provide additional safety precautions specific to the job site that may be needed before performing any other steps. CAT test question number 2. Chemical spills are considered A, toxic spills, B, routine spills, C, a problem if it is an acid, D, a problem if it is a caustic. Answer A is the best answer here. Answer B is not correct because the answer is too vague and that a spill that occurs on rare occasions would not be considered routine. Though answers C and D could be correct, they are not the best answer because they do not take into account all aspects of a chemical spill because a spill could be either acids or caustics. CAT test question number 3. Hazardous waste disposal is done by A, burning in an incinerator, B, single bagging in plastic bags and disposing in the regular trash, C, double bagging in plastic bags and disposing in regular trash, D, placing it in a designated location. Answer D is the best answer here because answers A, B, and C are all too specific and do not apply to all types of hazardous waste. Placing hazardous waste in its designated location takes into account all possible varieties of hazardous waste, which may have different disposal criteria. CAT test question number 4. Hospital personnel that are confused during an emergency should be A, left undisturbed, B, asked to stand by the exit door until you can get to them, C, given the rules for the emergency, D, assisted. Answer D is the best answer here. Answer A, B, and C are all too specific and do not accommodate for every situation. Each of the answers A, B, and C could be the answer for a specific type of emergency, but may not be applicable to another. CAT test question number 5. To protect personnel and guests from construction hazards, what should be done? A, barricade and mark the work area. B, close down rooms and walkways that are near to the work area. C, place an alarm that will sound high-frequency noises if persons are too close. D, verbally announce that persons are too close to the work area. Answer A is the best answer. Answer B is not the best answer because adjacent room and walkways do not always have to be closed down. Answer C is not the best because a high-frequency alarm could potentially affect patient care or be an unnecessary annoyance to those in the space. The noise could also startle the worker, causing a safety issue. Answer D is not the best answer because verbally announcing does not take into consideration those persons that may be hearing impaired or simply not paying attention. CAT test question number 6. When fire alarms sound, what should a maintenance technician do? A, ensure that everyone else is out of the area before leaving. B, turn off the electricity on the way out of the area. C, prevent everyone from using the elevator. D, follow your healthcare fire plan. Answer D is the best answer here because every facility is different. Answer A, B, or C may be a step to follow at a particular facility, but not another, therefore only following the particular healthcare fire plan can outline the exact steps needed when a fire alarm sounds. CAT test question number 7. What should the maintenance technician do if called to an area where a light fixture is throwing sparks? A, ask everyone to leave the area. B, turn off the electricity. C, use welding goggles to see where the sparks are coming from. D, activate the fire alarm and evacuate the area. Answer B is the best answer here. Answer A is not correct because it uses the term everyone. A fire watch should be left in the area with a fire extinguisher in the event the sparks start a fire. Answer C is not correct because gathering the welding goggles would take too much time and does not address the immediate hazard. Answer D is not correct because activating the fire alarm may not be needed in every incident. CAT test question number 8. A large leak has flooded an area. What should the maintenance technician do first? A, turn off the water to the area. B, barricade the area. C, place slippery floors signs in prominent locations. Or D, get a mop. Answer A is the best answer because it directly addresses the terms large leak and flooded that are used in the question. Answer B, C, and D all use terminology more closely related to a small spill. CAT test question number 9. A particular job will create a large amount of dust. What should be done? A, isolate the work area leading to all other areas. B, place a fan so that it blows into the work area from the patient areas. C, exhaust the dust out a window. D, capture the dust by running a vacuum cleaner while working. Answer A is the best answer. Answer B is not correct because without isolating the work area, the dust will eventually make it back to the patient areas. Answer C is not correct because the type of dust is not identified. Therefore, exhausting the dust out of a window cannot be determined. Asbestos or other hazardous dust may not be exhausted without filtration. Answer D is not correct because the term large amount is used in this question. A vacuum cleaner is not capable of capturing large amounts of dust. CAT test question number 10. A leak in the roof has caused a wet spot in an outside wall. What should be done? A. Use a heat gun to dry the spot so that it doesn't contaminate other areas. B. Treat the repairs as if it contains mold spores. C. Remove the wall covering before it grows mold. D. After it dries, cover it with a good grade of enamel paint to reduce mold growth. Answer B is the best answer, because a worker should treat the repair as if it contains mold spores. The question does not address time, and therefore we cannot defer whether it just happened or occurred many months before. Answer A is not correct because the heat gun may not be able to dry internal components like wood studs. Answer C is not correct because the wall covering might already have mold growing on it. And answer D is not correct because it does not correct the mold problem. Comp Test 1, question number 10. Picking up a heavy load involves A. Bending at the waist and picking it up with one movement. B. Bending at the legs. C. Getting a pry bar to pick up one end. D. Getting the rigging crew to move the load. As shown in the photo, answer B is the best answer to prevent worker injury. Note that D is not correct because the question specifically states picking up. Comp Test 2, question number 10. Hazardous waste spills are cleaned using A. Chemical pumps. B. Absorbent socks. C. Sawdust-like material spread over the spill. D. Special wet-dry vacuums and chemical filters. Answer B is the best answer here. Absorbent socks are specifically manufactured to clean up hazardous waste spills. Comp Test 13, question number 10. Not stepping on the top step of a ladder is practicing what type of safety? Answer B is the best answer here, because ladders are considered a piece of equipment that are used by facility personnel when performing maintenance or repairs. Comp Test number 14, question number 10. Safety should be practiced A. While you sleep, B. Every day, C. Once a week, D. During safety week. Answer B is the best answer because it is the most comprehensive. Safety should always be practiced at all times. Therefore, answers A, C, and D are too narrow to be correct. Comp Test 15, question number 10. Fuel, oxygen, and an ignition source are needed to A. Produce an electrical problem. B. Create a fire. C. Get rid of hazardous materials. D. Start a car. Answer B is the best answer. The question is specifically referring to the fire triangle as shown on the screen. The fire triangle specifically calls out for an oxygen, a fuel source, and an ignition source. Comp Test 16, question number 10. Eliminating the chance that forces could be unleashed on you or others is called A. Common sense. B. Lockout tagout. C. Reasonable precautions. D. Depressurization. Answer B is the best answer because the purpose of lockout tagout directly addresses the need of eliminating the chance that forces could be unleashed on you or others. Answer A, C, and D are all incorrect terminology and should not be used to describe the purpose of lockout tagout. Comp Test 17, question number 10. A safety standard is described as which of the following? A, a state law. B, an approved practice. C, a code requirement. D, healthcare preference. Answer B is the best answer here, because an approved practice best describes a safety standard. Both answers A and C would be considered regulations, and answer D is too vague and refers to choices that do not have to be approved by a review process. Comp Test 18, question number 10. Air contamination can be caused by which of the following? A, gels. B, dust. C, fluids. D, oxygen. Answer B is the best answer. Answers A and C cannot, generally speaking, cause air contamination. Answer D itself can become contaminated, but it would generally not contaminate another air source, as asked by the question. This concludes our safety and support section of the CSHE MECH study guide.